Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture 12 of module 1, and in this lecture we will be discussing continuous learning in agentic systems. So if we look at the lecture overview, like what we will be discussing in this lecture or what this lecture is about. So see, the idea is that no agent is perfect at deployment. No agent is perfect at deployment because even the best designed system will encounter edge cases, novel tasks, unexpected user behavior, environmental shifts. So the idea is that the agents you will be designing, we cannot cover all the possible scenarios. There might be many edge cases which will be left out. There will be many novel tasks which the agent might encounter after deployment. Unexpected user behavior is very common because agent will be in a very uncertain world. So the idea is that if an agent cannot improve with time, it will drift out of alignment. It will accumulate errors. It will lose trust and it will become obsolete. So there is a need for agents to continuously learn. So that is what this lecture is about. Continuous learning in agentic systems. We cannot have a perfect agentic system, like no agent is perfect at deployment, because once the agent is live, the agentic AI application is live, it can come across several edge cases which it has never seen before. It can come across novel tasks which it has never encountered before. It can also come across unexpected user behavior and environmental shifts. And in those scenarios, our agentic AI systems, they might hallucinate or they might get puzzled because they have never seen such scenarios before. So they don't know how to deal with such situations. So there is a need for continuous learning in agentic systems because if an agent cannot improve, it will drift out of alignment. Like whatever the goal the agent was supposed to accomplish, it can drift away from that. It can accumulate errors, it can lose trust, and it can become absolute. So the idea is a static agent, it degrades. So a agent cannot be static. Rather, we should have a learning agent because a learning agent, it will keep on evolving with time. A learning agent evolves. And that is what this lecture is. So in this lecture, we will learn how we can build learning agents or how we can enable continuous learning in agentic systems. So it is going to be a very important lecture. So if we look at the topics that we will be covering in this lecture, so we'll talk about why static agents fail. Then we will talk about agents that improve over time, reinforcement learning in agents, learning from feedback, incremental knowledge updates, model updates versus memory updates, experience based improvement, long term performance gains, safe learning and guardrails, designing the improvement loop, common anti patterns. And finally, we will conclude this lecture by discussing the philosophy of evolving systems. So, all these topics we will discuss in some good detail in this lecture itself. So, this is the module 1 Introduction to Agents, lecture 12 Continuous Learning in Agentic Systems. And we are starting with the first topic of this lecture, why static agents fail. So, static agents, they rely on fixed prompts, frozen models, predefined workflows, and unchanging policies. over time, problems arise. See, static agents, they are very rigid in nature because they rely on fixed prompts, frozen models, predefined workflows, unchanging policies. So with time, these static agents, they encounter several problems. Like, see, with time, data distribution will changes. Data distribution changes, and hence static agents, they start failing. User expectations evolve. So static agents, they start failing. Business rules update with time. So static agents, they start failing because static agents are based on fixed things, fixed workflows. Tools behave differently, and hence static agents, they start failing. So there is a need for adaptation. Without adaptation, if the agent is not able to adapt with time, performance slowly declines. The performance of static agents, it will slowly start declining. Errors will start compounding, and confidence will erode. So the idea is very clear why static agents fail. Now it's very clear to us. So static systems, they assume stability, but real environments are dynamic in nature. Real environments are dynamic in nature, and hence static systems, they fail. They cannot survive in the real environment, which is highly uncertain in nature, which is evolving with time. Wherein in the real environment, it's dynamic. The data distribution is changing, user expectation is evolving, business rules are getting updated, tools are behaving differently. And static systems, they assume stability, and hence they cannot survive in real environments, and hence they fail. Agents that improve over time. So definitely we need dynamic agents which can improve over time. So if we talk about agents that improve over time, so these agents, what they do, what is so special about them? So these agents, they learn from its own success and failure. So agents that improve over time, what they do is that they keep on reflecting on their actions, like whatever actions they are performing, the outcome of that, they are reflecting on that, like they are learning from their successes and failures, and they are adapting, they are adjusting decision strategies based on that. So a learning agent, it keeps on learning from its own success and failure. It keeps on adjusting decision strategies. It keeps on refining tool usage. It keeps on updating knowledge sources, and it keeps on incorporating user feedback. So now it's very clear to us that, okay, if you want to design a continuous learning agent, then you should have all these capabilities in your agent, wherein your dynamic learning agent should learn from its own success and failure. It should be capable of adjusting decision strategies. It should refine tool usage. It should update knowledge sources. And very important, it should incorporate user feedback. Now, here one very important point. See, improvement does not means retraining model. Here, model means the large language model or the foundation model I'm talking about. See, we cannot retrain the model on fly. When the agentic AI system is running, we cannot retrain the model. Retraining the model is like a very complex thing. So improvement does not mean retraining the model. Then what is the meaning of improvement? So learning agent, it improves over time. It means it will improve the orchestration. It will improve the memory usage. It will improve the policy layers. It will improve the prompt strategies. And it will improve the escalation logic. So very important discussion we made. Improvement does not mean retraining model. Rather, improvement means improving the orchestration, improving the memory, improving the policy layers, improving the prompt strategies, and improving the data escalation logic. So continuous improvement is multi-layered. So continuous improvement means we have to improve the different layers of an agentic AI system, and also incorporating like the learning agent should learn from its own success and failure. It should incorporate user feedback, and based on that it should adjust decision strategies, refine tool usage, and update knowledge sources. All that it should do. Reinforcement learning in agents. Now let us first understand what is reinforcement learning like in agentic system. So the idea is that, see, agent, we know that agent can perform an action, like it can perform actions to accomplish goals. So let us suppose we have an agent, it is performing an action A. So when the agent will perform an action, the environment will it will get affected. We can see some changes in the environment. Now agent will receive a feedback. Now this feedback, we call it the reward. Now this, see, agent did some action in the environment, and from the environment there were some outcome, so some changes in the environment, and agent received a feedback from the environment. Now that feedback can be positive, it can be negative, and based on the feedback, agent will adjust the behavior. Based on the feedback, agent will adjust the behavior, and then once again agent will perform an action with adjusted behavior. Environment will get affected, agent will receive a feedback from the environment, and it will once again adjust the behavior, and it will keep on doing it until it receives a very good feedback from the environment, or until the goal is achieved. So this loop is what like we are, this is what is the reinforcement learning is. So if we talk about key components of reinforcement learning, so we have something called as state S, that is the current context, action A, which is a decision taken, reward R, which is a measure of success, and policy phi, which is the strategy for choosing actions. So in any rein reinforcement learning, we will have a state, which is the current state of the system, the current context, the action taken, and because of the action, the environment will get affected, and the agent will receive a feedback. So that is a reward. It's a measure of success whether agent is in the right direction or not, and based on that, agent will adjust its behavior, and policy is the strategy for choosing actions. Now reinforcement learning in agent systems, if we talk about, so in agent systems, reinforcement learning, it applies to tool selection. So while selecting the tool, agent systems, they can apply reinforcement learning, wherein they can choose different tools, and whatever tool is giving them the best reward, they can go with that. Agent systems can apply reinforcement learning in deciding planning strategy, in deciding escalation timing, in deciding resource allocation, and in deciding confidence calibration. So in agent systems, reinforcement learning concepts apply to tool selection, planning strategy, escalation timing, resource allocation, and confidence calibration. See, agents, they can adopt reinforcement learning inspired mechanisms even without full RL training. See, the idea is that in agent systems, we are not fully using reinforcement learning. Rather, we are using a mechanism which is inspired by reinforcement learning. For example, in agent systems, we will be using the concept of reward signals from success metrics, penalties for failure, and optimization over repeated interaction. Like there is a loop, we will keep on optimizing until the goal is achieved. Penalties will be given for failure, and reward will be given for success. So the idea is reinforcement learning introduces learning through interaction and not just pre-training. So definitely any agentic system, any agentic AI application, it will be making use of the foundation model, and foundation model is pre-trained. That is for sure. But we already saw that static, pre-trained model is not enough, because the agentic system will be operating in a dynamic, uncertain world, wherein it needs to keep on evolving. adapting with time, with situations, with scenarios. So just pre-training is not enough. There is a need to learn on the fly, and that we can accomplish through reinforcement learning, wherein the agent, the agentic system will be learning through interaction. The agentic system will be learning through interaction, learning from feedback. So this is also very important, wherein agents they can learn from the feedback. Now the feedback can be explicit feedback, wherein agents can learn from user corrections, ratings, approvals or rejections, human reviews. So external feedback is the one which the agent receives from the outside world, from the environment, like user correction, rating, approvals or rejections, human reviews. We also have implicit feedbacks which the agents receive internally from components. For example, task completion success. So whenever any task gets completed successfully, a component will receive a feedback. So it's an implicit feedback. Time to resolution, escalation frequency, retry patterns. So these are like examples of implicit feedback. Like let us suppose it's the time to resolution. Then a particular component will receive a feedback that it's time to resolution. Escalation frequency. Now let us suppose there is a need to update the escalation frequency. So a component which is responsible for escalation will receive a feedback conveying the escalation frequency, and based on that it can alter the escalation mechanism. So these are examples of implicit feedback. So the idea is agents they should log feedbacks systematically. They should adjust decision thresholds based on the feedback. They should refine prompts or policies based on the feedback, and they should keep on improve confidence scoring. Now this feedback, it must be, so this is also very important, whether it's explicit feedback or implicit feedback, the feedback must be structured, feedback must be actionable, and feedback must be integrated into the improvement loop. Because without structured feedback, learning becomes accidental, not systematic. So for a systematic learning, feedback has to be structured and actionable. So because without structured feedback, learning becomes accidental, not systematic. So now we saw that if I talk about continuous learning in agentic systems can keep on learning from feedback on the fly. Incremental knowledge updates. See, agents, if we talk about, they rely on external knowledge sources. Like agent systems, they rely on databases, they rely on documentation, they rely on policies, they rely on APIs, they rely on regulatory data. So agents, they rely on external knowledge sources. Now, incremental updates, it ensures that knowledge remains current. Outdated information is replaced. New rules are incorporated. So the idea is very clear. So incremental knowledge updates means the knowledge sources, the external knowledge sources which the agent rely on, we have to keep on updating those external knowledge sources. Let us suppose you are making an agentic AI application which uses several databases. We have to incrementally keep on updating those databases. Documentation, policies, APIs, regulatory data. So we should keep on updating those knowledge sources. So that is the incremental knowledge updates. Because if we are doing that, then so incremental knowledge updates, it ensures that knowledge remains current, outdated information is replaced, and new rules are incorporated. So the idea is we have to keep on updating retrieval systems. We have to keep on refreshing indexed documents. We have to keep on adding new tool capabilities, and we have to keep on expanding knowledge graphs. So we can achieve incremental knowledge updates via updating retrieval systems, refreshing indexed documents, adding new tool capabilities, expanding knowledge graphs. So incremental knowledge updates, it improves accuracy, it improves relevance, and it improves reliability. Model updates versus memory updates. Now, the distinction between model updates and memory updates is very critical. It's very important. This distinction is critical. So, if I talk about model updates means updating the foundation model. Whatever foundation model I'm using, updating that is the model update. So, model I can update via fine tuning. I can fine tune the model via retraining, via upgrading to a new foundation model, or via changing architecture. So the idea is that in an agentic system, I can update the model. Either I can go for a new foundation model, or I can update an existing foundation model via fine tuning or retraining it, or by changing architecture. Now see, model updates, if I talk about, they are expensive because fine tuning and retraining is not easy. It's expensive. They are very time consuming and very complex, so infrequent. We rarely think about fine tuning or retraining the model, but the impact will be very high. Like, let us suppose if you are updating a model, the impact of it will be very high. On the other hand, if I talk about memory updates, it's about adding new interaction history. So memory updates means the we are updating the context, we are updating the memory, because we know that large language model, or any foundation model like the large language model LLM, it is stateless. It does not have a memory of its own. Whatever you will ask it, it will just reply that, and it will forget also the interactions. It cannot remember interactions. So we make use of the memory where we will store the interactions. So memory updates means adding new interaction history, storing user preferences, updating learned patterns, and improving retrieval context. Now, memory updates, since we are just so what we are doing is that whatever prompt we are giving to LLM and whatever response we are getting, we are storing it somewhere in the memory, and we are calling it like the interaction history. User preferences we are storing in the memory, so that we can make use of it. We can give those user preferences as prompt, as additional context, so that LLM response will be more personalized. So memory updates, they are lightweight, they are continuous. We will keep on doing it, and low risk. So the idea is most agent improvements happen through better memory management and orchestration, not full model retraining. So in most of the scenarios, in majority of the scenarios, we will not at all consider model retraining, because model retraining is very expensive. It's very complex task. So rather in agentic AI systems, in agentic AI applications, we will be rather involved in memory updates. So in better memory management and orchestration. And understanding this distinction is very important, because understanding this distinction prevents unnecessary complexity. We can prevent unnecessary complexity. Experience based improvement. See, over time, agents, they accumulate experience, like which tools succeed. So the idea is that now, when the agent is live, it is working in the real world. It is learning from experience, because it is experiencing new edge cases, novel tasks, and based on that, it is learning. So that is the experience based improvement. So over time, agents accumulate experience. So agents will learn which tools succeed. Agents will get to know which plans failed, which user patterns repeat, they will learn user patterns also, user behavior, which escalation paths are effective. So this is like a very powerful learning wherein with time agents they are accumulating experience. Agents they are getting aware about which tools succeed in real world, which plans fail, which user patterns get repeated, and which escalation paths are effective. And this is what is experience based improvement is. And this experience based improvement, it is very, very powerful and it is very helpful wherein it allows faster decision making, reduced retries, because agentic system has already learned the, the best practices. So retries will get reduced. We will get higher success rates because now with experience agentic systems they know the recipe, they know the best practices. So we will get higher success rates and better confidence estimation. And that is what is experience based improvement is about. So experience it transforms an agent from a generic, because we start with a generic agent, and with experience that generic agent will become contextually intelligent. And this context is very important. This contextual intelligence is very important in continuous learning in agentic systems. So this is the experience based improvement. Long term performance gains. Now see, basically the idea is that continuous learning in agentic systems, it enables reduced failure rates, improved latency, higher user satisfaction, lower operational cost, and better alignment. So basically, with continuous learning in agent systems, performance gains compound over time. With time, like we will get long-term performance gains. So with continuous learning in agentic systems, performance gains compound over time, wherein we will be able to reduce failure rates, improve latency, high user satisfaction, lower operational cost, and better alignment. So let us suppose we have an agent which is deployed for 1 year with continuous learning. An agent with continuous learning, it is like let us suppose deployed for 1 year. So 1 year of experience it got. It is so powerful that it will outperform a static agent with stronger initial decision. So initially our continuous learning agent might be very dumb, but with 1 year of experience, it will outperform a static agent which was initially very strong. Because in static agent, the graph is like a horizontal line. With time, it will not at all learn. Whatever the initial perfection it had, it will get stagnant. It will remain there only. It will not at all improve at all. So the idea is improvement beats initial perfection. So rather than putting more efforts on initial perfection, we should put efforts in improvement because improvement beats initial perfection. Safe learning and guardrails. Okay, now it's very important. Like when we talk about learning, continuous learning in a agentic system, that learning has to be safe learning. So the idea is continuous learning must be controlled because if it is unsupervised, so unsupervised adaptation can lead to drift, drift from the goal. Unsupervised learning, unsupervised continuous learning can lead to policy violations, reinforcement of incorrect behavior, exploitable patterns. So this is very important that in agentic AI systems, definitely it is continuously learning. So the learning must be controlled. So we should go for safe learning. And what is safe learning? So safe learning, it requires version control, monitoring changes. So the idea is that whatever the learning the agentic AI system is doing, it is getting reflected. So we should monitor the changes. We should monitor its behavior, whether after learning it is going towards the right direction or not. Safe learning requires controlled rollouts, A/B testing, human approval loops. Human approval loops will be very important in safe learning. So the idea is the continuous learning agentic systems, it must be measured, reversible, and auditable. So the learning should be measured, it should be reversible, wherein we should be able to undo the changes, we should be able to unlearn, and auditable. So this is like a very important discussion we made, safe learning and guardrails. Because if the learning is not safe, if it is unsupervised, then the agentic system, instead of improving its performance may degrade, wherein it can drift away from the goal. Policy violations we can see, reinforcement of incorrect behavior, or exploitable patterns. Designing the improvement loop. So a mature agent system, it includes several layers. Like we will have observation layer. Observation layer, what it will do is it will be involved in logging the performance. It will log performance and tracks outcomes. We have evolution layer, evaluation layer. Evaluation layer, it will evaluate, it will measure success metrics, it will detect degradation. We will have adjustment layer, it will update prompts or policies, it will refine thresholds. And we have validation layer, it will test improvements safely and monitors impact. So we are discussing the improvement loop. So the idea is that we start with the observation layer. Observation layer, it will observe, it will observe the performance and the outcomes. It will log the performance, it will track the outcome, and then it will give it to the evaluation layer, wherein the outcomes, evaluation layer, it will evaluate the performance and the outcome, wherein it will measure the success metrics, and it will also detect degradation. And based on the evaluation, the results of the evaluation, it will be given to the adjustment layer. The goal of adjustment layer is to adjust based on the current performance. So adjust means updating prompts or policies and refining thresholds. And whatever adjustment we did, we will validate it. So validation layer will test the improvement safely, and it will monitor the impact, and we'll keep on doing it. So this is the improvement loop. Now this structured loop, this improvement loop, it ensures continuous growth. Because with, if this loop is running continuously, it will definitely ensure continuous growth. Because whatever observation we are making, like observation means we are observing the performance and the outcome, we are evaluating it, we will get to know where the model is where the agentic system is degrading, where its performance is degrading, and where it is doing good. And based on that, we'll do some adjustments. And that adjustment, when it is done, we will validate the we will test the improvements, and then once again we'll keep on observing, tracking the performance and outcome, and we'll keep on doing it. And every time we'll keep on adjusting, and this will enable continuous growth, controlled evolution, and reduced risk. So this is a very important discussion. Like continuous learning in agentic system, if you want to do, you have to consider this improvement loop. This we should have in place. Okay, common anti patterns. Now let us talk about some common anti patterns while dealing with continuous learning in agentic systems. So these anti patterns we should avoid. So deploying and forgetting. So deploying and forgetting means, okay, agentic system, we just deployed and we forget. So it's like a static. It will not keep, it will not learn with time. So that we should not have. No structured feedback capture. So that's an anti-pattern. Rather, we should have a structured feedback capture. Updating everything at once. So that is also very important. We should not update everything at once. Rather, continuous learning should be with time. Blindly trusting reward signals. we should not blindly trust reward signals, ignoring long-term drift. So this is very important. We cannot ignore long-term drift. Meaning to say that if agentic system is showing long-term drift, we have to take it very seriously, because drift means drifting from the goal. And after a point of time, agent will completely drift away from the goal and it will get stuck. So rather we should go for better approach. And that better approach is, rather than updating everything at once, we should focus incremental improvements. In the previous slide, we saw that loop, that is an incremental improvement. Measured experiments, transparent logging, human review mechanisms. So we should have all this in place. So continuous learning in agentic systems, it involves incremental improvements, measured experiments, transparent logging, and human review mechanisms. The philosophy of evolving systems. Now see, the idea is that continuous learning, it reflects a deeper truth. Intelligence is not static, it is adaptive. Intelligence is not static, it is adaptive. So see, this, it is very clear to us, because we saw that if we are using a static agent, it will fail in the real world. And why intelligence is not static, it is adaptive? Because the real world where we live in, where these agentic systems will operate, it is highly uncertain, highly dynamic in nature. So intelligence system has to be adaptive, wherein these intelligence systems, they will learn and adapt. So agent systems, they should improve gradually, they should adapt responsibly, and they should evolve strategically. So this transform agents from being software tools which are very passive in nature to organizational assets. So this is the core essence of this lecture, that agentic systems should be evolving systems, wherein it should continuously learn, it should improve gradually, adapt responsibly, and evolve strategically. And with this, these agentic systems, they will become organizational assets. So the software tools which were very passive in nature, it will get transformed into organizational assets. So that's the philosophy of evolving systems. So finally, we completed this lecture. So in this lecture, you got a very good understanding why static agents, they degrade over time, how reinforcement learning concepts are applied to learning agents, to agents that continuously learn, the importance of feedback loops, this you understood, the difference between model and memory updates, the difference between model updates and memory updates, and how experience drives long-term improvements. So I hope you got a very good understanding of the concepts which we discussed, which we covered in this lecture. So do subscribe to our YouTube channel, ScaleUp University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.